Okay, right. So today we are discussing about the OSI layers. Okay, first, uh, why we want to use the OSI layers. Let me tell you, one quick example. Like if you are getting some courier or some letter, you will not get it directly, right? For example, you go and post at some office. Again, they will collect and they will put it some in transit, whether it is train or whether it is flight, whatever it is. Like if you can see DTDC or Blue Dot. So again, it will reach that major destination look or hub. From there, again it will be distributed, right? So means at each level, it's having like specific scope of work. So similar way, a network engineer want to troubleshoot a network, he need to know that mainframe, like how network will be, how the traffic will be passed, and for what issue, which layer will be the responsible. If you know this, your troubleshooting is easy, right? And first, why this OSI concept is why this OSI layer concept is came? Because, for example, earlier, if we have a Dell computer here, and if you have HP computer here, so you are not able to communicate because his manufacturing style is different and his manufacturing style different, and his sports manufacturing is different, and this HP manufacturing. So if a Dell computer or if a Dell device want to communicate with the HP, it is not possible. Similar way, we have network devices like you have a HP router and you have the Cisco router. Again, if we do not have this OSI model, then we cannot connect to these different vendors, right? So to make communication easy or to communicate between the different vendors, so there is a standard process we brought it, that is OSI, Open System Interconnect. So either whoever it is the manufacturer, they have to follow this flow, right? Now, whatever the manufacturer, so different vendors can communicate with different devices without any problem. So that's why OSI came part. It is came into the picture. Now here we have total 7 layers. So the first layer is, if you start a network, this is the, sorry, okay. First will be like physical layer, okay. Physical layer. What is physical layer? So in OSI layers, this is the first layer is responsible for the hardware. For example, we sometimes see, right, here user will come connect, then he will connect to some switch, right? Then he will connect to some router again, right? First of all, if some communication is not happening, first what is responsible? These devices are responsible. Then the cables or the media we use to connect these different devices. So this media might be the problem. So this is the first problem. So in the first layer, if your command, for example, someone user called and he said, I'm not able to reach this. Then first we have to see about the physical layer, right? So in physical layer, what things will come? Like hardware, it may be computers, it may be routers, switches, printers, and including even cables. Okay, these all will comes under the physical layer. So whatever you feel and touch, so those are comes into the physical layer. And here, the information passed in the signal form. Okay, again. So now we understood, right? Physical layer is responsible for hardware part. So whatever is communication broken, so first we have to while troubleshooting, first our point should be whether physical part is good or not, whether my devices are good or not, whether he again, for example, sometimes you will call to our architecture will be different. Maybe for example, if you are a network engineer, so it is impossible to go and monitor each and every device. So you will sit in the NAC room, and here one field engineer will be there. Okay, this is a real time. You have to use these terminologies. Now, so you have one jump box. So it from this jump box, you can access any device. For example, if I'm working for the 3 different locations like EMEA, AMR, and APAC, you are the network engineer, you are troubleshooting, you can access these all 3 regions. You can access all devices using this jump box, right? Fine, till here it is fine. Now you are sitting here, okay? So you are saying for me in the EMEA region, router 1 is not reachable. So what you will do first? So you will guide him. So everywhere we will have the design. So first you will see the design, or else even you can ask him like just go to the network room, then go to this. Every device have its a serial number, right? So you will provide him serial number. Go and identify this device. Then you will ask him now. So what is the line indication on this? Whether it is green, whether it is red, whether it is amber. So if he says this is in red, then your device was down or it's a critical. If it is amber, it is functioning, but something is fault. If it is green, all good, right? So now you got the information. For example, your engineer is saying your router is green, but still you are not able to reach. So one step is completed. Again, you will ask him, okay, fine. So total, like any cable is connected to this router. If cable is connected, what is the port light indication? LED light indication. Again, so again, if this is good, if this is not good, you will ask him, hey, just jack in, jack out this cable. We will call it as an uplink port. Just jack in, jack out, right? Then your issue might be resolved, right? So these are the basic and important troubleshootings. So, so for this part, these all troubleshooting comes under the physical layer, right? Fine. Now we are good with the physical layer. Then what is the next layer is data link layer. Okay. So again, you are going here data link layer. Data link layer. So data link layer, it is the second layer. This is what it will do. This second layer, yesterday we discussed, right, some switches, L2 switches, L3 switches. Your L2 switches comes here. Okay. Layer 2. So physical layer, it deals with the hardware, cables, whatever router printers. And your data link layer, it deals with the MAC address. It deals with the MAC address. So generally here it like L2 switches comes under here, or hubs will comes under here, and it deals with the MAC address. So here the traffic, that format we call it as a frames. Okay, here the, for example, you said like whether frame is for passing or not, frame is reachable or not. So here we will call it as a frames, right? Here we have the L2 devices like switches, hubs, and it deals with the MAC address. Here data flows in the format of frames, and this is responsible for MAC address. MAC address is nothing but your physical address, right? For example, we yesterday discussed ARP. We discussed about the ARP. Can anyone say like what ARP can do? Anyone can say like what address resolution protocol can do? No problem, right? So it deals with this. Now fine. Then again we'll go to the network layer. So network layer. What is network layer? So network layer, it deals with the IP address. Okay. It deals with the IP address. So here your routing will comes picture. Your routings will come, your IP address part will come here. Okay. And it deals with the dedicatedly IP address scheme. Right. Now we discussed yesterday one thing. A switch can understand, layer 2 switch can understand only MAC address, and your router can only understand IP address. Then how it will be translated? We discussed yesterday this part. So ARP will be helpful. Address resolution protocol. What is its main function? Its main function is if a frame is coming from switch to router, it will say, it will translate from this MAC address to IP. MAC to IP. If a packet is going from here to here, then same ARP address, it will translate like IP to MAC. I'll show some example as well. So whenever like someone is saying, hey, my server is not in network. First you will see there is one command is there. I'll show in few minutes. You will give show ARP. If you are not learning the MAC address or if result is coming as incomplete, you will say first your device is not in network. First check it whether it don't have power or it might be having some IP problem or it you can give you might have given the wrong subnet mask, right? In network layer, so we will deal with the IP address. Then next layer is transport layer. And by the way, we discussed right here the traffic will pass in the form of frames. Traffic will pass in the form of frame. What about in network? In network, it will pass in the form of packets. Here we will call as a packets, right? In network layer, we call it as a packets. Then transport layer, right? So transport layer, it will write on top of this network layer. So what it will do? Generally, we will see, right? TCP communication, UDP communication. Anyone heard about the TCP UDP? Please speak, no problem. If you know, don't know, no problem.
Yes, sir.
Yeah, any idea
Yes, sir.
what a TCP can do, what a UDP can do?
It is a transmission control protocol, and
Hmm.
UDP is
No problem. So this transport layer protocol, what it will do? It will deals with the TCP, UDP, and ports. Ports. First, what is TCP UDP? Okay. What is TCP UDP? TCP
yeah,
is
it's
transmission.
user datagram protocol. I
Right.
remember now.
Right. So TCP, thank you. So TCP, it's a transmission control protocol. First, okay. Then what is the difference between TCP and UDP? TCP means transmission control protocol and UDP is a user datagram protocol. So TCP, it is a connection oriented protocol. It is a connection oriented protocol. And this one is connectionless protocol, right? So connection oriented protocol means, for example, Here one system is there, here one switch is there, or might be application, you are communicating this. So here you have the complete end-to-end understanding, or you have the proof. So if it is traffic is somewhere it is blocking, or somewhere it is um, discarding, then you will see, you'll go here till here your packet will discard. Then you can understand, okay, I'm able to go till switch. Even from switch it is going to out, but from switch it is getting discarded, okay, or dropping. So this complete end to end you have the visibility. So that is connection oriented. You means you can know what is happening. And user datagram protocol, it is a connection less protocol. You can send the traffic, but you are not sure whether it is reached or not, right? So now you say which one is fastest protocol, either TCP or UDP? Can anyone guess? Okay. So this UDP is the fastest protocol. Why? Because here I need to send the packet. Again, I need to give the confirmation. Hey, I'm sending packet from here to here. Yes, packet is reached. Again, you can send the packet, but here I'm sending the packet from once it is going, again it is sending the packet. Unless there is no layer 1, layer 2 issues, your packet, it moves fastly, right? Where we will use TCP, we will use in the like I forget this.
Telnet, HTTP.
Right, HTTPS. So
Yeah,
you can use here
HTTP,
and use it,
SMTP.
and FTP, right? File transfer protocol, and SMTP, simple mail transfer protocol. So multiple ways you can use. And UDP, like broadcasting, for example, like television or radio. So there you no need any feedback. For example, if television is not coming up, definitely you'll get the feedback, right? So where the broadcasting mechanism, there we are using the UDP. Of course, we are using in network as well in some other mechanism. It depends on, it is again your requirement, where you want the uh, connection oriented, where you don't want the connectionless. It depends on this, right? So it deals with the, again, like we discussed, right? HTTP, HTTPS. We know in like we have to have an idea about this protocols. HTTP, it number is 80. HTTPS, it is a 443. Okay, like you have to remember about the FTP. It might be 23, I think, and then SM
2021.
2021. Then SMTP. All right, you have multiple for SSH, secure socket.
Security.
So for this you will use
SL.
the port. For this you will use the port 22. Why will use the port? Like we discussed, right? Network engineer want to access network devices, so that will be accessed through port 22. Okay, right. Now transmission layer, it deals with the TCP UDP and ports. Then presentation layer. Okay, I think session layer. Okay, session layer will come then. After transport layer, session layer will come. What is this session layer is responsible for? For example, you are sitting here, you are accessing google.com. Okay, you are using the google.com. So you access the google.com and you are not using from past 5 minutes, right? What it will do, it will terminate the session. Else, if everyone connection is, then this Google server might become slow, right? If you are not using for certain time, there will be threshold is there. If within the threshold, if you are not using, then it will be session timeout. Again, you have to reload the page. Similar way, we are using VPN connections. So same, it needs to authenticate. So there will be some username passwords and it needs to match that condition. If all good, then it will say whether termination should session should start or stop. So session part will comes under here, session establishing, session termination, and even like sometimes your applications as well. So session based is there, right? Sometimes you can see this page cannot be displayed, right? So these all we can set in the load balancers and right. Okay, I'll give some examples. Here I have, okay, we are here. So these are the certain protocol like PPTP, SAP, L2TP. So these, but the major functionality of this session layer is like session establishing and session termination. Then like yesterday we discussed, right, encryption, decryption. So this encryption, decryption, everything will be taken care in the presentation layer. And also one more thing we have to address in the TCP UDP, we can uh, divide the large data into small data. Again, this large data we are dividing and we are sending. So that will be again uh, formed in a certain form. For example, you are sending a picture. So it divides the data and it will share as a pieces to not lose the data. If data load is more, we have a chance to lose the traffic. So in TCP, in transport layer, data will be divided as a pieces and it will be sent. Again, same pieces will again it will form data here. In application layer, what you are seeing when you are entering in the browser, so what you are seeing is where applications visible here, application visible, right? Like HMTP, HTTP, DHCP, FTP, whatever it is. So these are the things, and we covered these are layers like physical layer, data link layer, network layer, transport session and presentation layer, right? Again, we discussed, right, how the data will flow. In the physical layer, we will call it as a bits, okay? In data link layer, we are calling it as a frames. In the network layer, we're calling it as a packets. When you went into the transport, it is a segments. So remaining all layers, we will call it as a data. Okay. So this will be like example, what comes under the physical layer, like cables, fiber, wires, and hardware devices. What data link layer deals with this PPP, MAC address, frames, network layer, like IP address, IPsec tunnels, transport layer, like we discussed TCP, UDP, okay, and session layer, like where like session establishment and termination will be decided here. Presentation layer, where your pieces of data, which is divided in the transport layer, is uh, gathered here. It gives a certain form to the data. And application layer, where you are in front page, where you are able to see the data. Okay. Right. So TCP UDP we discussed. In TCP, this is one of the important question you might get in the interviews. Okay. For example, what is TCP three-way handshake protocol? Anyone have idea? This is when you are going, especially those who are going in a basic level, they must get the this question. Okay. For example, if this is your client, this is your client and this is your server. Okay. So what client will do, it will send the sync packet to server. Okay. Right. It will send the sync packet to the server. So what it will do, your server, it verify this field or this sync packet from which source I'm getting the sync packet, to what destination it is coming, and what is the service port it is using, right? And it will verify these fields. Once it is verified, and if it had that required information, then it will validate here, right? Okay, I received the sync packet from you, and yes, I received it. I'm sending the acknowledgement. Now the initial packet is sync packet came. Now server adding the acknowledgement to this, right? Now again your client will verify, okay, this is the sync packet I have sent to my server, and my server added this information, right? What is the destination I mentioned here while sending in the sync packet? What is the destination I mentioned here? Now I'm able to see the destination. So I reach the proper destination and I'm getting the proper response from the destination. Then you receive the confirmation here, right? Confirmation here. Then your traffic will start. It will be processed again. So you can go ahead and start the your then your genuine traffic will pass. Initially, it will establish the path. Then actual data will be processed. Just I'll show one more example here. TCP 3WAY handshake. Right here, we will send the sync packet from client to server. Then again, we will get the sync along with the acknowledgement from the server. Okay, then after seeing complete this data, we can share the acknowledgement. Now actual data will be communicated between the client and server, right? Second thing, anyone like had that, for example, you are a network engineer, right? So you have multiple devices. For example, you have a system 1, system 2. Likewise, you have system 500. What happened? Now, okay. Like you have system 1, system 2. Okay, system 500 you have. So how you will give IPs to these all? Anyone idea? If we can give manually, but after giving 100 IPs, it is not necessary we are humans. We may forget. Again, if you give the repeated IP, you will get the conflict. So you won't get the network, right? For that, we are using the DHCP mechanism. What is DHCP? Dynamic Host Configuration Protocol. So what it will do, it will use the DORA process, DORA. Discover, offer, request, acknowledgement. For example, you have one client machine. Again, you have one server machine. What client will do? First, it will broadcast, and it will by default DHCP server, it have the pool of IPs. DHCP server maintains the pool of IPs. So your client will get the one IP from the pool. Now your client asks, hey, I received this IP. I discovered this IP. Can you assign this IP? Then what it will do, this DHCP server, it will verify it's a pool, whether this IP I'm having free or somewhere it is assigned. If it is assigned, then it will right away it will tell, no, I cannot assign this IP. If it is a free IP, then what it will do, it will again offer, right? Whatever the IP you're requesting for, I'm okay to assign you, right? So then again, it will like request, then it will confirm, right? It will first, it will discover, then it will offer, then it will confirm, right? This is the process will happen. So this one document I will give you here, somewhere I mentioned. Yeah. So this is a simple way you can understand what it will do. Like this way you can understand. So your client machine will discover your server machine. If that discovered IP is free, then it will offer. If once it is offered, then again it will request, okay, assign me this. I'm accepting this IP. You can resort it in your database. Then yes, it will say I resort it, and it will share the acknowledgement. Okay, so this is the DORA process. So any questions as of now? So today what else we discussed? We discussed OSI layers, and we discussed what is TCP and what is UDP, and differences between TCP UDP, and we discussed like how we are assigning as a network engineers, how we are assigning the IPs. So two ways we can give: one is static, another one is dynamic. Static means you will go manually and you will assign. So manually you will give. Static means manually. A dynamic means there is a server. It is a DHCP server. It is reserved with the pool of IPs. It will offer the IPs whenever there is a network device in the network. So it will offer the IP. So using this DHCP protocol, it uses the DORA process, and it will assign the IP address, and it avoids the IP conflict or using the duplicate IPs. So we cannot use one IP at a time, like twice. Okay, these all are we discussed. So any questions in this? Ryan or Rehan, Raghavendra, and Pranay, all good or any questions?
Yes, sir. I do have one question.
Yeah,
So
please.
in dynamic protocol, we do have RIP, OSPF, and EIGRP, right? So,
Again, those are the protocol. Those are different.
yeah. So, are we gonna discuss about that too?
Yeah, definitely.
Yes.
We'll
Okay.
go step by step, right?
Yeah. Okay.
Right, and we'll connect after 10 minutes. We will see like basic things in the Cisco packet tracer. Okay.
Yeah. Sure. Sure.
Okay then. Thank you all.
Sure.
We'll connect
No
after
problem.
10 minutes.